Hi guys, I'd like to welcome all of us to my channel of Honest Sciences and Mathematics TV channel. We're going to, of course, look at a continuation of what we have been studying on various aspects of organic reactions. And today we're going to look at the concept of bond breaking and bond formation in organic reactions. Now, this is going to form an essential part of understanding most of the organic reactions that we're going to encounter in our various discussions. Particularly in trying to consider the movement of electrons, of course, which of course are going to result in the formation of a new species in the products or within the intermediaries, as we are trying to, of course, interpret different reaction mechanisms. So for today, we're going to look at these two basic concepts of bond breaking and bond formation. Now, earlier on, we had looked at the concept of valence electrons, and this basically, as we said, part of of course, electron proliferation. This section of an atom is what basically is involved in chemical reactions through the exchange of electrons, and in some parts we're going to see that there's going to be a sharing of electrons, especially on organic compounds, which we had spoken about in our introduction to organic chemistry. And then we see about the formation of covalent bonds, which specifically is displayed by much of the organic compound species. So in this particular case, we're going to look at this second aspect and try to see how chemical reactions can be interpreted using the bond breakage and bond formation. And in some aspects, we are going to encounter what we refer to as radicals, and I'm going to explain what basically is referred to as a radical in chemistry. So therefore, we're going to start with the concept of bond breaking. And in this bond breaking, the process is going to result in the formation of other species of either ions, molecules, or atoms. And I'm going to use a general example to illustrate this one in the concept of maybe a dissociation of atoms which form a compound. So in case we have maybe two different atoms for A and B joining together, these are going to form a product AB. So if this was an organic reaction, then therefore this is going to be a covalent kind of bonding that's going to be experienced for this if we, of course, try to narrow down to our main element in organic chemistry, which is carbon. It's going to bond covalently with the other compounds. So for our general case, then therefore we'll assume that this is a covalently bonded compound that is going to result from the interaction of A and B, which is going to have two pairs of electrons. It's alone, this is a pair of electrons that is being shared between these two particular reacting species to form this specific compound for AB. Therefore, if you try to split this specific compound in the process of what we call bond breaking, we will have two different species of products which are going to be referred as radicals. So therefore, we'll have A with that pair, that part of pair of lone electron, and B having one electron as such. So we refer to these specific species which are products as radicals for A and B respectively. And later on, we're going to see that this specific, we mentioned them at one point in organic chemistry, but basically a radical refers to a free atom, or rather is known as a free radical in some literature, refers to an atom or molecule or an ion that at least one pair of just a single part of that pair of lone electrons, which is of course the valence electrons that we had said, which are of course undergoing covalent bonds in organic chemistry. So for A containing one electron from this pair of electron from the compound, A can be referred to as a radical, B can be referred to as a radical. So therefore that in an essence refers to what we call a radical. So breaking of bonds results in the formation of a radical, and for this one we call this one homolytic bonds. So this is an homolytic kind of a bond breaking process that is taking place in this specific kind of breaking. And in us trying to refer to the concept of homolytic bonding, sometimes this one can be referred to as homolytic fission, and fission is the breaking or forming some kind of a cleavage, and therefore it's going to be referred to as homolytic fission or homolytic bond breaking. So therefore, in homolytic bond breaking, we're going to see that the process is going to entail the breakage of a molecular bond by evenly distributing electrons between the resulting fragments for A and B, respectively, as I've already explained. So that is one way in which we're going to experience bond breaking in organic compounds. The second one, we're going to see that this bond breaking can result in the formation of a product species that is going to wholly possess this lone pair of electron, and the other resulting species that is going to be experienced from this particular kind of bond breaking is going to be a positive charge. So we can be able to illustrate that one showing those lone pairs of electron, and this is going to be having a negative and a positive charge as such. We have already discussed the concept of electrophile and nucleophile, and we can visualize this one from that specific aspect, considering the product for A as a positive, which is an electrophile, and B as a negative for a nucleophile, respectively. So in this case, for what we refer to as heterolytic bond breaking, this results in the formation of a polar product, of course, which we can see carrying those opposite charges as we have illustrated on the board. And this basically, the two electrons are going to stay with one fragment, as I've explained. And in heterolytic bonding generally, then therefore, we can be able to describe this process as a process of a cleaving or breaking of a covalent bond, where one previous bonded species take both original electrons, as we have seen for P, that is possessing all the electron, while the other one is going to remain to be positive. So therefore, we can be able to describe this bond breaking in these two illustrative general examples. But I can just give one example of an organic species that is undergoing this kind of bond breaking. Now, suppose I take this alkane member, which is a 2-carbon member of the alkane, or the hydrocarbon, which is going to undergo bond breaking. I'm just going to use this reverse arrow. So we're going to have two product species which are going to be formed from this, whereby we're going to have this one having just one electron and another one. So this is an example of what we're going to refer to as homolytic bond. The products are going to form radicals which are each having a single electron from the pair of electrons that was shared in the formation of this head-to-head bond in this specific case. So this is going to be carbon radicals. And in the second case, where we had spoken about one species, of course, containing all the lone pairs of electron, we can just use a similar example. But on the product side, we're going to see that this is going to result in the formation of what we refer to as that particular product. And I'd given this one as analogous to a nucleophile, whilst the other side is going to form an electrophile that is going to consist of course of what we refer to as a carbocation. So this is a formation of a carbocation, and this is a carbanion that is going to be formed, and two respective parts for the product's species. And in this case, of course, these are going to give us a general example for the 1 and 2 illustration that I've given for the formation of a radical and a polar product, as I've shown above. So that's the case for bond breaking in organic reactions. So next I'm going to look at the concept of a bond formation, and that is going to be, of course, a control example, which is going to give of course, an opposite example. But we're going to see that in this particular case, there's going to be either one electron donated by each fragment, or 2 electrons donated by one fragment to form a specific bond. So catch us in our next video as we're going to look at bond breaking, so that it can form a comprehensive part of this bond breaking and bond formation in organic reactions. So that is it for now, guys. Bye. Let's catch up in our next video.